Hello everyone. Welcome to SHR Trinity. Welcome to part 4 of our zero-shot prompting interview series. Let's get started. Before we begin, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now begin with questions 31 to 40 of our zero-shot prompting interview series. Moving on to question 31, how do you minimize prompt latency in high-throughput zero-shot endpoints?
In high-throughput enterprise systems, latency is dominated by two factors: the time to first token generated by the model, and the total token payload of the prompt. Zero-shot inherently solves the payload size issue by removing examples. However, to minimize latency further, you must optimize the instruction syntax itself. Strip out conversational pleasantries like "please help me with this." Use imperative verbs immediately at the start of the prompt: extract, summarize, format. Furthermore, minimize output token count by explicitly instructing the model to avoid explanations, output the answer only. Do not provide reasoning. By compressing both the input syntax and restricting the output verbosity, you drastically accelerate the endpoint's execution speed.
Moving on to question 32, how do you integrate zero-shot prompting within a RAG pipeline?
In a RAG architecture, zero-shot prompting is the final synthesis step. The vector database retrieves the relevant context chunks, and you inject those chunks directly into the zero-shot prompt. The critical architectural rule here is boundary separation. You must strictly separate the retrieved data from the zero-shot instruction. I use delimiters like triple backticks or XML tags. The prompt looks like, "You are a technical support agent." Use only the information inside the context tags to answer the user's question. If the answer is not in the context, output, information not found. This zero-shot constraint prevents the model from hallucinating outside the retrieved RAG data.
Moving on to question 33, what is the role of system prompts versus user prompts in zero-shot architectures?
In modern chat API architectures, zero-shot instructions are split between the system message and the user message. The system prompt is where you establish the core operational rules, the persona, the negative constraints, and the output format schema. The system prompt acts as the immutable guardrail for the session. The user prompt, conversely, should only contain the specific task data or question for that iteration. For example, the system prompt says, "You are a JSON translator. Return only valid JSON. Do not converse." The user prompt simply says, "Translate this text to Spanish." This architectural separation ensures that the zero-shot constraints remain dominant across multiple API turns, preventing the model from forgetting the rules.
Moving on to question 34, how do you handle edge cases and undefined inputs in zero-shot pipelines?
Because zero-shot pipelines lack examples of edge cases, you must build explicit fallback logic directly into the instruction. If an LLM receives garbled input or data outside its domain, its default behavior is to guess or hallucinate an answer to please the user. To prevent this, a professional zero-shot prompt establishes a default denied posture. You explicitly state, if the input text is blank, garbled, or not related to finance, do not attempt to answer. Output exactly the string, invalid_input. By providing the model with an approved exit ramp, you allow your downstream application code to cleanly catch the error state without parsing hallucinations.
Moving on to question 35, how does zero-shot prompting performance scale with model size?
Zero-shot performance scales almost exponentially with model parameter count and pre-training data volume. Small, edge-deployed models, like a 7 billion parameter model, often struggle with complex zero-shot formatting because their parametric memory and reasoning depth are constrained. They usually require few-shot examples to stabilize their output. Conversely, frontier models like GPT-4 or Claude 3.5 Sonnet exhibit emergent reasoning capabilities. Their vast pre-training allows them to execute highly complex, multi-constraint zero-shot prompts flawlessly. In an interview, explain that choosing between zero-shot and few-shot is often dictated by the size of the underlying model. Massive models excel at zero-shot, while smaller open-source models often demand few-shot anchoring.
Moving on to question 36. What is zero-shot chain of thought, zero-shot COT, and how does it work?
Zero-shot chain of thought is a breakthrough prompting technique that dramatically improves an LLM's reasoning without providing examples. The classic implementation involves appending a simple phrase to the end of your prompt. Let's think step by step. When the model sees this phrase, it triggers an autoregressive unrolling of its reasoning process. Instead of jumping directly to the final answer, which often leads to calculation or logic errors, the model generates intermediate reasoning steps, consuming tokens to think. This technique bridges the gap between the speed of zero-shot and the logical accuracy of few-shot, making it invaluable for math, logic puzzles, and complex problem-solving.
Moving on to question 37. How do you evaluate and benchmark the success of a zero-shot prompt?
Evaluating zero-shot prompts requires a systematic, automated testing framework rather than manual vibe checks. Because zero-shot relies entirely on instruction clarity, even a one-word change can alter the output distribution. To benchmark, I build a golden dataset of 100 diverse test inputs spanning nominal, edge case, and adversarial scenarios. I run the zero-shot prompt across this dataset and evaluate the outputs using two methods: deterministic regex checks for formatting compliance, e.g., valid JSON, and LLM as a judge evaluations, where a larger model scores the outputs against a rubric for tone and accuracy. This quantitative approach allows me to definitively prove that a prompt revision improved the system's reliability.
Moving on to question 38. What is the risk of prompt injection in zero-shot applications, and how do you mitigate it?
In zero-shot pipelines, prompt injection occurs when a user embeds malicious instructions into the data payload, causing the model to abandon the developer's original instructions. Because there are no few-shot examples anchoring the model's behavior, zero-shot prompts are particularly susceptible to this hijacking. To mitigate this, you must construct a robust prompt architecture. First, use strict delimiters like triple backticks to isolate the user data. Second, use a post-instruction reminder. Place the core system instruction both at the beginning of the prompt and explicitly repeat the negative constraints at the very end, after the user data. This ensures the model's attention mechanism processes your security constraints last, overriding any injected commands.
Moving on to question 39. How do you use zero-shot prompting for data anonymization?
Zero-shot prompting is excellent for redacting personally identifiable information, or PII, from unstructured text. To do this reliably, you must be explicit about the entity types to redact and provide the exact replacement token. Your prompt should instruct the model: review the following text. Replace all names, phone numbers, email addresses, and physical addresses with the exact string, redacted. Do not change any other words or grammar. This approach relies on the model's pre-trained named entity recognition capabilities. By specifying the exact string, redacted, you ensure the output format remains uniform for downstream processing without needing to provide examples of redacted text.
Moving on to question 40. When should you definitively abandon zero-shot and transition to few-shot?
You should abandon zero-shot and transition to few-shot prompting when you hit the instruction complexity wall. This occurs in three distinct scenarios. First, when the required output schema is deeply nested and difficult to describe in natural language. Second, when the task requires mimicking a highly idiosyncratic, proprietary corporate writing style that the model hasn't seen in pre-training. And third, when dealing with complex logical mapping, where input variables must be transformed using non-standard rules. If you find yourself writing a 500-word zero-shot instruction just to handle formatting edge cases, you are wasting tokens and engineering time. At that point, providing two clear few-shot examples is fundamentally more efficient and reliable.
Excellent. You've completed part 4 of our zero-shot prompting interview series. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next video.